Okay, so we're ready to do another slightly involved problem. Okay, once again, if you look at this, the basic concepts are straightforward, but sometimes the implementations gets a little tricky. So let's understand what you need to do, and then life is good. So you've been given logs. You've been given logs of dimensions 10 meters in length, and then 30 centimeters in the radius, and the density of the logs is 700 kg per meter cube, and the liquid density is 1000 kg per meter cube. And what it's asking is how many logs do you need in order to support an elephant. So we'll find the minimum number of the least number of logs to support an elephant of mass 5000 kg. So what you're going to have is you're going to have some number of logs, okay, some logs, and then you have an elephant, of course, of mass 5000 kg that goes into this thing. Let's put some ears on the elephant and the trunk and tusk. It's very important. Okay, so we have this elephant that's going to sit on this log. I know you think it's floating, but it's not really. It's all 3D view, so don't think I'm not thinking about that. All right, so we have this. It's there, and it's going to be supported. So stop here and ask yourselves, what am I supposed to do? How do I find the number of logs? Okay, what do I do? What concepts will I be using? Okay, so stop, and then before proceeding, think about all these things. Maybe write something down, maybe do the whole problem, and then verify your answer. Okay, so assuming that you've stopped, so I'm going to proceed. So what I'm going to do is I'm going to say, okay, let the number of logs be n. Let there be n logs. Let there be n logs. Okay, so what's happening in the problem is this: all these forces, the force of the weight of the logs is pushing you down. The weight of the elephant is pushing you down, and the weight of the water on the logs is what is pushing it up, the buoyant force. Okay, so it's a simple problem in dynamics. So what you have is your weight of the elephant plus the weight of the logs. Okay, and we want this to be just balanced by the buoyant force on the logs, the force of buoyancy on all the logs. Okay, so that's it. Now if there are n logs, then we can figure out the mass of n logs. Okay, so before we proceed, what I'm going to do is on the side here, I'm just going to do quick calculation of the mass of each log. So mass of the log is nothing but the volume of the log times the density of the log. Okay, this is, which happens to be 700 times pi times 0.3 square times h, which is 10. Okay, so this gives me the mass of each log. The number will, so it's going to be 700 times 2.83. Okay, which is the volume of the log, and this will be a useful number that will keep coming up, so it's good to just keep that aside. Okay, so what do we have? Okay, so we get 1981 kg for the mass of the log. Okay, now that we know the mass of the log, we also know its volume. We can proceed and do a bunch of other things. So what you have is you have what's it called? You have the elephant, and the mass of the elephant is 5,000, and we can multiply by 9.8 to get the weight of the elephant. Plus we have n logs, so the mass of each log is 1981. So I'm going to do 1981 times n times 9.8. Okay, so keep that in mind. Now all this is going to be equal to the buoyant force on all the logs. Now we're saying that all the logs are just completely submerged in water. Okay, so the entire volume is submerged, so have all the buoyant force due to all the logs, and that will be equal to the density of the liquid, which is 1000, times the volume of all the logs. So it will be n multiplied by 2.83, okay, times 9.8. So rho Vg. Okay, so keep this in mind. This is rho Vg, but the rho is the density of the liquid, and then V is the volume, and G is 9.8. Once again, you see we can get rid of all the 9.8s, and I have 5,000 plus 1981 times n is equal to 2830 times n. Okay, So it's a simple problem in algebra now. And what we have is we have 5000 equals 2830 minus 1981, which happens to be equal to 924 8 and 1. Okay. Oh, no, 849. Okay. Oops, there is an n here, so it's 849n, and so now I get n is equal to 5000 divided by 849, which is about 5.89. So it's approximately 6 logs. So that's what we need. We need a minimum of 6 logs in order to support the beautiful elephant. Alright, so that's that problem.